So what's going on? You have, as you alluded to, innovations going on in the broad field of nanotechnology, synthetic biology, and a variety of related fields that cross-pollinate with them. So what do I mean by that? Well, if you could control the placement of matter down to atomic scale and with atomic precision, and in many cases is using processes borrowed from nature to do this, you could build a more efficient solar cell, a more efficient battery, a more efficient membrane, perhaps use less material in a catalyst in a membrane. It's the waste of atoms, if you will, that ultimately drives the current cutting edge of many of these industries. So when A123 goes public, not one of our companies, they're a battery company today. They were founded as a nanotech company, right? A nanostructured cathode, where just having higher surface area on the cathode in a very controlled manner can improve the yield of any lithium-ion cell, and now lithium phosphate cells. So there are sort of scientific innovations down at the low level that are percolating up, and you wouldn't see them. You won't know there's nano inside, but it's the solar cell, it's the battery, it's the fuel cell that runs better. Similarly, in the biology space, there's a renaissance that's even more powerful, I would say, but maybe an order of magnitude more important and impactful, and that is that we're now re-engineering information systems of biology like never before. We're both deciphering the code of life and now writing the code of life as if it were a computer program. And a seminal breakthrough by synthetic genomics last year was pretty emblematic of that, at least as a sort of statement of what's possible today. They synthesized, for those maybe perhaps not familiar with it, a microbial genome from scratch with every letter of the genetic code synthesized in a lab with no animals involved, right? So give me an A, T, G, C, whatever you want. Just write the code as if it were freeform. They embedded web pages in the DNA. They just do anything you want. And they changed one organism into another, complete genetic alchemy. So this is emblematic, and as are some of the high-throughput evolutionary experiments that have been done, emblematic of new capabilities, new processes for doing biotech, what I call biotech 2.0, that weren't available to us just 5 or 10 years ago, where it's now cost-effective to do billions of experiments per day instead of 1 or 2 per year. And so the pace of progress in industrial biotech will go through a profound leap, I think, over the next 5 to 10 years. Why is this important? Well, these microbes consume hydrocarbons and carbohydrates and very precisely, with incredible chemical precision, convert them into others. And what are these? All the fuels and chemicals we care about, right? Just about everything you can touch in this room was made by oil. Because there's surface coatings and all this thing that looks organic, the floor covering, of course the carpet, the chairs, much of what you're wearing. And 90% of all organic chemicals come from petroleum. And so that's all going to change, right? One day that will come from other places. We'll be much more efficient in how we reuse and recycle. And microbes are the main workhorse for doing this because they're so much more efficient inherently in doing that. And they are green in every sense of the word. They don't tend to kill themselves as they manufacture stuff.